All right. Well, good morning, everybody. Thank you very much for joining us here now today. I appreciate you coming along. So my name is David Webb. I'm an automation and mechanical engineer with Reliance Automation. And today's webinar is the second in our series of webinars. We'll be running another few over the next few weeks. And the one following this one is going to be pneumatics replacement by Jerry Graham. So if there's an interest in that side of the business, please join us. Keep an eye on your social media links and your emails. We'll be sending out additional invitations for those. But today we're going to be talking about end of arm tooling. And what we'll run through is just a little brief introduction to Reliance and who we are for those who haven't been dealing with us beforehand. I'll jump into end of arm tooling then, explaining that and the different types that are typically available. And then the kind of considerations that you may have in picking the end of arm tooling for your application. And once we've gone through the kind of types that are out there, we'll have a look at the real world examples of some of the manufacturers that we represent and the types that are available. There's also an awful lot of resources then to be able to help assist you in the selection of the end of arm tooling most applicable to yourselves. And then at the end, we'll take a question and answer session. Now, at any time you want to raise a question, we've got some panelists on board with us now today. We've got Richard Mawson from OnRobot with us, and we've also got Ronan Rasdale from Reliance Automation as well. So feel free to ask any questions in the chat area, and the guys should be able to help you during that. Also, we'll be recording this session as well, so if there's anybody else who isn't on board there now today who wants to look at it, you'll be able to have a look at it at a later date. So firstly, just a brief introduction now into Reliance Automation. So Reliance Automation is a division of the Reliance company. So we were started back in 1925 in Cork. So we're nearly 100 years old now at this stage, into the fourth generation of a family-owned business. So originally it was the Reliance Bearing and Gear Company, but the portfolio has expanded significantly over the years. And we're now at a stage where one of Ireland's largest technical distributors now for automation and maintenance products. So typically we would operate in a lot of different areas, but we do have kind of specific focuses on food production, life sciences area, and kind of general manufacturing as well. And regardless of the areas that we're working in, we're always striving to provide a superior level of technical expertise along with excellent value and service. Now, we are an ISO 9001 accredited company, and we've also been essential workers during this time, so we've been fully operational, and we're here to support you in any of the requirements that you may have. So we've got 3 branches in Ireland. We have one in Dublin, we've also one in Limerick, and also our head office in Cork. So we've got a good spread across the country. Now, what's important to note is that Reliance are a distributor, so we're not an integrator. So an awful lot of the products that we would supply are kind of out-of-the-box solutions and are quite easy to set up for personnel who may not have a huge amount of automation experience. But on the other side of that, we also work with an awful lot of the integrators around Ireland. So if the project is a little bit more complicated or relies on that kind of hands-on requirements, we're able to work with these integrators, and they're based all around Ireland as well. So regardless of your location, we're able to service you. So now that we've just covered off on Reliance, well, let's jump into the main topic now today, which is end of arm tooling. So what is end of arm tooling? It's sometimes abbreviated to EOAT. You'll see that in a few documents, and end effectors is another word that's commonly used to describe it. So essentially, an end effector it's the device that the robot utilizes to interact with the environment around it. So regardless of if you're utilizing kind of a 2 or 3 axis simple tabletop robot or a very large 6 or 7 axis robot, regardless of the complexity, the robot requires that end of arm tooling to interact with the environment. So Essentially, without this piece of tooling, the robots, it's a big paperweight. It can perform a push function probably at the best of times. So the end effector is very, very significant in how that robot operates towards your application. So the end of arm tooling now, it's a significant part of the project. We also find that a lot of the time the end of arm tooling gets overlooked when people are looking at a robot project. Like they'll look at the cost of the robot itself, they'll look at the infrastructure in and around, the power requirements, safety, etc. And the end of arm tooling doesn't get the credence that it deserves. But it is a significant part, because without this end of arm tooling, it could be the difference to having a very reliable, robust application or having something that's completely uneconomical. So given the fact that it's so important, what are some of the considerations that we look at when we're selecting end of arm tooling? So kind of the first one is going to be your application. What is it that you're trying to achieve? And there's a number of factors that kind of come into this, like what's the payload of the part that you're going to be picking up? What kind of size is it, etc. So I'll go into a bit more detail on the application side on the next slides. Then we have a look at the actuation technology that's available. So is it an electric actuator, pneumatic, hydraulic, or is it a piece that doesn't require any energy source into it whatsoever, like an adhesive? And each of them has their own kind of benefits and specialities towards applications. And again, we'll go into a bit more detail on that. And we have a look at the cost. The cost can be direct cost of the actual piece of equipment itself, so the end effector, or it can be indirect costs, so the likes of the maintenance that's required to run the system. How often am I going to have to replace the part? If you're looking at changing the application and changing the end effector, how much downtime is required in between each part? So looking at the time then as well, leading on from that kind of downtime piece, is it something that's going to have to be changed an awful lot, or is it something that's going to be fixed in place? And then also the time in terms of your project. Like, have you got 2 or 3 months to be able to design an end effector that's going to perfectly fit your circumstance? Or is it a case that you've got a project that you've got to get up and running very, very quickly, and you need something that's out of the box, already programmed and very versatile to be able to take on no matter what application that you're looking at? Safety is always a big part as well. So in terms of safety, we can have a look at it in terms of, say, if there was a power outage, what would happen in that circumstance? Like if you've got a heavy part and the power cuts out, you want the robot to be able to grip that part as opposed to dropping it on the floor. And similarly, safety in terms, especially when we're looking at collaborative applications, where there's additional regulations that are involved in terms of how that interacts with the environment and the people around it, making sure that it's got nice smooth edges, nothing that's going to cut anybody if they were to come into contact with it. And then lastly, compatibility. So compatibility in terms of the robot that you're actually integrating it with, like is it direct software or is it something that you're going to have to program in? But also compatibility with the environment and also the product that it's picking up. So for example, if you're working in frozen foods, is it going to be able to pick up that frozen piece of equipment and not be detrimental to the end effector itself? Or something like a CSE application where it might be in contact with the lubricant that's utilized. So you need to ensure that it's got the correct IP rating so that nothing's going to get into the end effector itself and cause issues down the line. So these would be kind of the main considerations. Now there's another few as we go through, but they'd be covering off most of the major points that we look at. So to kind of go into them in a little bit more detail. So the application is probably one of the most important pieces. What we're looking at is the piece that you're actually looking to pick up or to interface with, and the sizing of that piece. So obviously, if it's quite a small piece, it's not going to need a smaller end effector. And similarly, a larger piece is going to need something with a much larger stroke on it. But then the variability of those, are you going to have a consistent piece the whole time? Or are you often utilizing a small piece 1 minute and a large piece again, and having something that's either going to be able to handle that or having two different end effectors? The weight and the payload then, as it's probably more commonly called in the robotics industry. How heavy is the part that you're going to be picking up? Is it a nice and light piece, or is it a much, much heavier piece? And we see all different ranges. We can be going down from something that's literally a few grams to something that's up in the hundreds of kilos on the larger robots. The shape of the part also plays a massive part. If it's something that's kind of symmetrical and very consistent, it can be quite easy to pick up at its sides. But then if we're looking at irregular shapes, then there's also a big consideration. It's about how we're going to pick that up. And also where the piece is located. Sometimes the optimal place for actually grabbing a part isn't necessarily reachable. So you have to adapt towards that. The surface of the part as well plays a big part in terms of the longevity of the actual grippers itself. Very rough pieces can be abrasive on the grippers. And then also, if it's a nice smooth piece of equipment, it can be quite easily to grab by vacuum, whereas if it's porous, vacuum technology may not be the best. We mentioned looking at the strategy of how you're going to grip it in terms of, for example, say you're working in a lab environment where you've got plenty of vials that are very, very tightly constricted together, and you may not be able to actually grab along the sides of those parts, where you've got to use a vacuum technology then to pick it up from the top. And then the speed of the application as well becomes very important. If you're picking up a part and moving quite slowly, the amount of force required to grab that part isn't going to increase too much over the movement. Whereas if you're moving at quite a fast speed, maybe 100 cycles a minute, it can have a significant effect on the moment of the part, and therefore how much force you require to pick that up as opposed to a static environment. So once we've kind of defined what the part is and the kind of the size and the weights, etc., then we can have a look at the types of different grippers that are out there. I suppose there's kind of three or so major types. The first being the traditional gripper. So this is probably the oldest type that's available now. Kind of comes in parallel sides, couple of fingers typically, but these can be adapted to be 4 fingers, 3 fingers, 10 fingers, depending on the size of the part that you're picking up. And they also can be angular, circular, depending on the part that you're picking up. Then we've got the restrictive type. So restrictive pieces are those that pick up a force or generate an attractive force, should I say, to actually pick up your part. So instead of grabbing it using contact force, you're talking about vacuums, magnetics, either permanents or electromagnets, or an adhesive force to actually stick onto the part and then push it off then at the end of the function. And these would be kind of your general types of grippers. They could be utilized for multiple different processes, and then onto your process specific pieces then. And these are very much focused towards a very individual process. So something like material removal in terms of deburring, sanding and applications, welding, etc. And this list is essentially endless. You can design up pieces for almost any application. And not directly type of gripper on itself, but something that could be integrated into these is that kind of adaptive piece. So the adaptive side of things is essentially adding additional sensors towards your grippers to give it that feel, so it can actually sense when it has picked up a part, or sense when it has come into contact with something to determine the force. So thinking of the own dexterity of your own fingers and that kind of feel that may be required for certain applications. And kind of not really included in this is vision as well, which could potentially be classified as a type of end effector, where depending on where you put it on the robot. But we'll be doing a session on vision systems specifically at a later date, because there's a fair bit involved in the different types of technologies there. So after we've covered off the kind of mechanical side of things, we look at the different types of actuation technologies that are available. I said these are kind of pneumatic, electronic, and hydraulic. Now, hydraulic side of things are typically for your very large pieces, ones that require an awful lot of force, so picking up hundreds of kilos. So although we do work with this side, they tend to be a little bit more project specific and designed for each task. So more so we'll be looking at the kind of collaborative and light industrial space. And within this, pneumatic and electronic tend to be the most common ones that you'll see out there. With pneumatic applications, these parts tend to be quite small in size, reasonably easy to set up in terms that you're only talking about programming on off, and they tend to be quite quick, and because they're very simplistic, they tend to be quite cheap now as well. The advantages of the electronic systems then tend to become in the high level of accuracy that you can get and the high level of repeatability that you can get. So although they tend to be a little bit more expensive, it's because you have a lot larger functionality in there and control. Now, in the past, these were a little bit more complicated to set up, but as the technologies have matured, it's becoming easier and easier, and companies are integrating softwares that it can be just plugged out of the box and interface directly with your programming. So an off of them can be an awful lot easier than in the past. So once you've selected the type of grippers that are suitable for your application and the actuation technology that's going to be most beneficial to you, there's a number of kind of additional features then that you can have a look at. And things like the actual fixing of the machine itself or the end effector to your robot. So if it's an application that's going to stay the same 24/7, 365 a year, semi-permanently fixing it by bolts is perfectly adequate. Whereas if it's something that's maybe like a mobile robot that you're moving from application to application around a factory, you don't want to be taking off those bolts every time you have to move it around. Something like a quick changer that's a simple release of a button to change the tool heads to a different application may be more beneficial. There's also the cable management as well. An awful lot of these grippers, especially with the electronic type, go directly into the flange of the robot or through the flange of the robot, whereas the pneumatic types tend to have lines that run external. But there are some that run through the gripper itself, and also some of the robotics, like we have the Nachi robots that actually have the lines throughout the robot arm itself, so you don't have any of these pieces going around it. And then how many grippers you want for your application. So again, an awful lot of the time, a single gripper is perfectly adequate, whereas there are some applications out there, such as say CNC tending, where it can be beneficial to have two grippers so you can both pick up a part and load a part in the same movement. And that's going to depend on the cycle time of your application as to how much return on investment you get in and around that. So now that we've had a look through all the kind of considerations out there, I wanted to show some of the examples of the products that are actually available. So one of the companies that we work with are OnRobot. And OnRobot have been around now for a good few years, and they have a very, very large selection of robots and effectors for a variety of different applications. So the easiest thing for me to do is just show you a video of this. So here we see some of the different styles of the robot arms that OnRobot have available. And at this point, I just wanted to state that kind of although Reliance are distributors for universal robots in the collaborative space and Nachi in the industrial space, we can support end effectors for various different types of robots. So OnRobot are compatible with pretty much most of the major robotic manufacturers you have out there. They all run off the same platform, so it makes them very, very easy to interchange and change over for different applications very quickly. And I stated they've got that quick changer that makes this very, very easy to achieve. said they've got a wide range of applications. So like the force torque sensors there built into the 2-finger grippers. Also the vacuum systems, which are very, very adaptable in the terms of their sizing and also the amount of force that they can generate. So it just means that just with one product, you're able to facilitate for a large amount of different pieces. Now, OnRobot are releasing products at an exceptional pace at this time. And given that this video is only a couple of months old, there's an awful lot of applications that they have that have just come out now within those last couple of months. So I'll jump into a couple of those in a bit more detail. One of the newest ones that they've come up with is the 3FG15, and it's very literal, the naming. It's a 3-finger 15-kilo payload. And what's great about this design is it utilizes rotational force on the grippers as opposed to your standard linear actuation stroke. And what makes this great for is the likes of CNC machining of cylindrical billets. So they can grab a hold of them and centralize them within the gripper, moving them onto the machine then afterwards. They're also, again, same with all the lots of the OnRobot pieces, they're very adaptable. So you can move the grippers in and out depending on the piece that you're looking at. You can also change the material on the end of the grippers. So you see there, they've got the nice rubber soft fingers, but you can also remove that so that you've just got the steel on steel contact for pieces that might be a little bit heavier and you require a larger clamping force onto. During the video, we would have seen the VG10, which is the large vacuum gripper. Well, this one is the VGC10. This is the compact version of that, and the little brother of the other one. And it's a very, very small piece. And what's great about this is, although it's a vacuum system, the piece is controlled by electronics, and there's actually a motor and a vacuum system within the tool itself. So you don't have to have pneumatic lines running separate to the system. Again, it's highly customizable, as you can see in the pictures. So something like the likes of the extended single gripper there, again, great for when you're using something in a very tight space, such as those vials within a lab environment. And you also have the option of running dual channels on it. So it's got A and a B channel. So you can suck up one part and keep the other channel closed. So you can actually pick up 2 different parts with the same gripper. So very, very flexible in terms of what it's be utilized for. And we mentioned the different types of actuation technologies and pneumatics and hydraulics. But one of the ones that is available is something that doesn't require any external energy source at all. And this is the Gecko Pad. So there's a larger version of the Gecko system, which is an electronic version, but this one is actually just a standalone piece. And the way the Gecko technology works is it's inspired by the geckos, and it's got thousands of little microfibers on the head of the piece that clings onto it when you apply a force. So these are typically utilized for very small payloads, kind of only up to about 5 kilos or stuff. But what they're great for is the likes of, say, mobile phone screens, where you don't want to be leaving any marks on the piece itself, or something like a PCB board where you've got plenty of holes in it, so it can't be picked up by vacuum technology. This can grab onto the flat pieces that don't have the holes on them. And how it works is you just simply push down on the part to grab a hold, and then when you want to release it, just put an angular movement, and that will actually release the part. So very, very simple in the fact that there's no programming of the actual end effector itself. It's all within the robot head. And these are just a couple of the examples of them. OnRobot, as I said, are releasing plenty of other ones, and they've just released their new soft gripper as well. And speaking of the soft gripper side of things, we look at soft robotics. So again, I'll just play a short video here. Now, what's great about the soft robotics is they are very, very versatile in the types of products that they can pick up. Like pretty much all pieces that I've come across can be picked up by these. They also do a food grade version of their parts so that they're compatible with the likes of chicken breasts and steaks, or any piece that requires that kind of non-contaminated grippers. Now these are powered by pneumatics, so they've got two different versions of it, so you can run it off your own pneumatic system, or again, they have a control box with a motor in it that creates its own vacuum. And essentially, they pull a vacuum to expand the piece and then put it under force to contract the fingers. And depending on the range of that determines how large the fingers open and close, and then how much pressure you put on determines the force. And they've got quite a modular design as well. You can see they have the two finger setup there with the short fingers, or they can have a lot longer fingers and then up to kind of 10 or 12 different fingers going on. Another company we work with are the Zimmer Group. And the Zimmer Group are a little bit unique in the fact that they do kind of truly pneumatic pieces, as well as electronic, and also a combination. So intelligent pneumatics is what they call them. These are very, very robust grippers. There's quite a large amount of them in the range depending on the forces that you require, so they can be quite specific to an application. An awful lot of them come up with a large IP rating on them as well, so that they're compatible with various different types of environments. And they also have kind of nice features in there as well, which can track the maintenance of the parts, so to tell you how many cycles that you've run through, so that you know when it's time to actually maintain that gripper itself. Now, although they do an awful lot of kind of single grippers like these that you see, one of the major benefits of the Zimmer technology is that they're extremely modular. So if it is a case that you've got something that's not quite a standard application, you can add several parts in together to be able to address the application that you have. They also have the likes of a automatic tool changer as well. So for potentially environments that you can't get into to change the head on them, they utilize a pneumatic system to be able to automatically change the heads on those, which can be beneficial. Sorry, getting a bit ahead of itself. Now, one of the more product specific tooling that we sell is that from Dynabraid. And Dynabraid manufacture sanding and polishing heads. So these are pneumatically operated again, and they have both orbital and random orbital styles. And they can also provide a vacuum system or an air system as well, mobile, so that they can be brought along with the robot to different types of applications. Now, the device itself is rather simplistic. It's essentially kind of on-off operation and utilizing pneumatics to control the speed. So it's the robot itself that actually performs most of the functions in this. So they can be utilized in industrial robots as well as collaborative robots. But something like the universal robot seen in these are quite good for these applications because they've got the inbuilt force torque sensor on the head. So you don't have to combine additional elements into those pieces. And kind of last but not least, we've got the likes of DINSA welding torches for robotic applications. And we provide these through our partner in Olympus. And again, just due to the amount that's kind of required in the explanation for the different types of welders, we're going to be running a very specific application seminar on robotic welding and the considerations behind that now in a few weeks. So if that's something you're interested in, let us know and we can send you off an invite for that application, or we can talk directly. And that's just a bit of a taste of some of the different types. And as you can see, there's a huge amount of variety in all the types that you can get. So in order to help you kind of select which is the best for your application, there's a numerous amount of resources that are available there. So Universal Robots have an application builder. And although this is kind of primarily designed for the actual kind of programming of the robot for itself, what it's really, really good at is taking you through step by step on several different types of applications. So whether that be kind of palletizing or CNC or machine tending, it actually walks you through every step and provides good explanations about the different types of grippers to help you kind of select which one would be best for your application. And that ties in with the whole UR Plus and UR CAPS infrastructure that they've got available. A number of the manufacturers also provide configurators for their tools. So like Soft Robotics, where you can go in and actually customize your tool for your application. So deciding on how long the fingers can be, how big the spacers have to be for your part, how many fingers you're going to need to grab a hold of it. A huge amount of e-learning and blogs and different literature is also available online. So on Robot, I've got a great book on talking you through your applications and going through the return on investment calculations and how to properly select that piece of equipment for your operation. Again, pretty much all of them have videos and case stories. So if you head on to any of the manufacturer sites and type in your application or even type in the type of product that you're looking to pick up, you'll get numerous examples on grippers that have performed those tasks in the past and showing you how it can be done. And kind of last but not least, ourselves here at Reliance Automation, it's exactly why we're set up, is to help you through the selection process. We know the ins and outs of all these pieces, as well as having access to all the technical specifications. So once we can know your application, regardless of if you're looking at it for the first time and don't have a huge amount of experience, or if you've already got a robotic line set up and you're just looking to optimize the application, we can help select the piece of equipment best suited to yourselves. So feel free to contact us at any stage and more than happy to help. Again, at the moment, it'll probably be limited to phone calls, but with the use of Skype or Zoom or videos or the rest, we can look through all that and help support. All right, well, that takes us to the end of the seminar. So I'll just have a look there and see if we've got any questions. Yeah, so if there's any queries that you have at this point, feel free to drop them into the chat section. I'm just going to open that up here now myself. I see our other panelists have been online there throughout. So yeah, what I'll do is I'll call it there. But if there's any other questions that you have, feel free to drop us an email and we'll talk about it online. So thank you very much for joining us there today. And as I said, keep an eye out as we'll have some other webinars running in the next few weeks. All the best.